Hello guys, my name is Dylan, my YouTube channel is DRG Bros, and welcome back to another video. Today we are going to be doing Numerical Integration 1. So as usual, our first topic is the review. And so there are two common types of integrals, but there are more, such as double integrals that we will cover in a later video. So these two common integrals are called indefinite and definite. So indefinite integrals have no limit. And so let's say x dx. And indefinite integrals always give us a formula. But definite integrals have limits. So this one goes from 0 to 1. And these always give us a number. And so definite integrals are an area under a curve. So if we take an integral, and the limits are b and a to b, and it's f of x dx. All we can draw is our curve. Here's our curve. It's not the best. But so this is the area under the curve right here. And so we can label this B and A. And so this integral right here is the area under the curve. And so for the area of the rectangle, we have a rectangle. It's always width times height. So this is going to be topic 1. So let's do topic 2. So this one's going to be sequences. And so this one is going to be pretty easy. So what we're going to do is we're going to draw our sequence. So those of you who don't know, a sequence is basically a pattern. So 1, and then next we will have 2, 3, 4, 5. So this is our sequence, and we can do 6, 7, and then etc., etc., etc. And then we can do another one. In this one, let's say 0, 5, 10, 15, and then etc., etc., etc. But so the patterns in these is this one you add by 1 and this one you add by 5. So 8, 9, 10, 11, 12, 13, so on. And 20, 25, 30, 35, 40, 45, 50, so on. For those. But what if we do this? So it's 1, 2, and then it's 4, and then 8. So what this one is going to be, and then this will continue on. So what this one is you are multiplying by 2. So instead of the next one being 10, it's going to be 16, and then 32, and so on and so on. And then let's do this one a little bit harder. So it's 1/2, 1/4, and then 1/8, and then etc., etc., etc. So what we're doing in this one is we're doing the same thing as we did in the last one. We're multiplying it by 2. So 2, 1/4, 1/8, 1/16, 1/32, 1/64, and so on. And then this one is going to be 1/1, 1/2, 1/3, 1/4, etc., etc. So this one's pretty simple. You're just adding, or you're dividing. No, you're subtracting. You're adding one of those. You're adding one to the denominator. And so the next one is going to be pretty tricky, so see if you can figure it out. So it's going to be 1, 1, 2, 3, 5, 8, 13, etc., etc., etc. So does anyone know the pattern? Well, the pattern is you add these two numbers to get this number. You add these two numbers to get this number. You add these two to get this number. You add the most recent two to get the next number. And so this one is called the Fibonacci sequence. And so when we look over it, this one is going to be an arithmetic one, not arithmetic, arithmetic. And so is this one. And so arithmetic sequences are when you're adding them together. Like you're adding them. So 1 plus 1 equals 2. 1 plus 2 equals 3. You're adding 1 each time. And then this one you're adding 5 each time. And so what we can do is we can do a formula to always know what comes next. So this is going to be A over N equals N. So what we can do is every time you have one of these, this is going to be A1, like A2, A3. So A just represents the number, like what number is in the sequence. So A1 is the first number in the sequence, A3 is the third number in the sequence, A2 is the second number in the sequence, so on. So AN, so if we do A7 is always going to equal N. But if we replace N with 7, then A7 equals 7. So that is this formula. And so the next one is a little bit more complicated, but we can still make a formula. So this one's going to be A sub N equals 0 plus 5 0 minus 1. And so if we replace, why is there anything there? So if we replace n with 6, a6 equals 0 plus 5, 0 minus 1. Oh, so this is an n. So a6 equals 0 plus 5, 6 minus 1. So it's 0 plus 5, which is 5, times 6 minus 1, which is going to be 5. So that the sixth number in the sequence is 25. And so the next type is geometric, and this is when you multiply them together. Like 1 times 2 equals 2, 1 times 2 equals 2, 2 times 2 equals 4, 4 times 2 equals 8, so on. So these are geometric. These two are. And so these both have their formulas. So a over n. And so this one is going to be equal to 1 times 2 n minus 1. So a3 equals 1 times 2 to the power of 3 minus 1, which is going to be 4. And the third number in the sequence is 4. And so for this one, we're going to do a sub n equals 1/2 times 1/2 n minus 1. So for this one, the third number in the sequence, a3 equals 1/2 times 1/2 3 minus 1. So that would be 1/8. And so the final type for this one is harmonic. And so the harmonic one is an easy one, so it's a sub n equals 1 over n. So a sub 3 equals 1 over 3, which is 1/3. And so the Fibonacci one is a lot more complicated. So it's a sub n equals a sub n minus 1 plus a sub n minus 2. So for the third number in the sequence, it's a3 equals a3 minus 1, which is 2, plus a 3 minus 2, which is 1. And that will give us a third number in the sequence. So we're on to our final topic now, which is going to be partial sums. So for say, let's do s sub 3 equals. So if you and we're gonna do the first sequence that we did. So 1, 2, 3, 4, 5, 6, 7, 8, 9, etc., etc. So what this means is the sum of the first three numbers. So 1 plus 2 plus 3 equals 6. And so for the next one, so 3 equals 0 plus 5 plus 10, which equals 15. And so for our next one, though, we're going to do S4. And this is going to equal 1 plus 2 plus 4 plus 8. It's the first 4 numbers in the sequence. So let's do it for our next one. S4 equals 1/2 plus 1/4 plus 1/8 plus 1/16. And so this one is going to equal 15 as well. And so this one is just going to be a 1/30th. So that's the harmonic one. But this time we're going to do S of n. And so how does this work? So what we're going to do is it's going to be the same thing. 1/1 plus 1/2 plus 1/3. And then etc., etc., until we get to 1/n. And so S of n for our first one is just going to be the same thing as 1 plus 2 plus 3, so on until n. And then S of n but what if we did it backwards? So we're gonna start with n plus n minus 1. So n plus n minus 1 plus n minus 2. And then etc., 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 until you get to 1. And so these two ideas can be grouped together. Now, what if we did 2 as sub n? And so this is going to equal n plus 1 plus n plus 1 plus n plus 1, etc., etc., etc. You're always going to end up with n plus 1. Now what if we did 2 s of n equals n plus 1? Did it backwards. And so this is going to give us s of n equals n plus 1 over 2. And this is going to be a key thing in our next video. Thank you guys for watching. I hope you enjoyed, and I'll see you next time. Bye.